Hello, Allie girl. While you were slaving away in the kitchen, we were slaving away with our homework talk. So, catching you up, we were talking about these formulas, how to use these in section 5.7. So, we were expecting integrals that either lined up and became arcsine, arctan, or arcsecant. So, we'll discuss probably three of them. Let me set a timer here. And if you would write these down, we would appreciate it. Let me get my stopwatch going. All right, so I don't go over time. All right, number 4 from the first set of homework, we had to do, let's start at number 2. Number 2. It was the integral of dx over 1 minus 9x squared. Oops, reading the wrong one. Sorry. 1 dx over square root of 1 minus 4x squared. So right here. Now, when I'm looking at that one, I go ahead and make a box. And it's good training for those. You probably may not need it as much on this one, but I recognize that I'm trying to line it up like this one. So I need to identify A, U, and DU. So going back, I can see that my A is 1, my U is whatever was squared. We have to have something that's squared, and once I've identified that U and squared it, it will equal 4x squared. So do you see it has to be 2x? That's when I square it, it becomes 4x squared. So now, in addition, let's have the du. Let me see if I can get this a little better. The du is just 2dx. And if I go back up here and substitute everything in, I need a 1/2 out here, a 2 in here, 2dx, and this can remain like 1 squared minus 2x quantity squared. So now we can see clearly what happens. So the 1/2, the 2dx from my box is my du. In the bottom, I have an a squared. Under the radical, I have an a squared minus a u squared. So that is exactly what I was hoping to get. So I know that the answer will be related to the arcsine. So it's going to be the 1/2 comes along for the ride, the arcsine of u over a. So what is my u? 2x. And what is my a? Just 1. So I end up with 1/2 arcsine 2x plus c. So it's like a u substitution problem. Let's go ahead and let me zoom out just a little so you can see a little bit more at once. All right, the next one I want to talk about is number 4. So as you were making a box for this one, you can see that we're probably going to follow this formula up here where it's 1 over a squared plus u squared. So we need to find an a and a u. And looking here, my a again is 1. What was squared to get 9x squared? My u is 3x, and my du is 3dx. So this is going to line up. I'm going to pull the 12 across the integral sign. 12, and I need a 3dx from my box, a 3dx. So coming over here, I'll put in a 3 and then a 1/3. That's one way of doing it, thinking about it. And then I would have dx over 1 plus 1 squared plus 3x quantity squared. So moving into u land, the 12 over 3 becomes a 4. This is a du, I'll pull that back in the screen in a second, over 1 plus u squared. So when I look back at my formula up here, moving all around, I'm going to use that, and it will become, we have the 4 who's still playing along, and we have arctan and our u in our box. Our u is, sorry, it's kind of slowing down here. My u is 3x, my a is 1, so u over a becomes 3x plus c. But I forgot something here. Up here I just noticed in the formula there's a 1 over a. Oh, I know. In my box, a is just 1, so it would have been a 1 over 1 right here, which doesn't affect anything. So that's why I didn't deal with it earlier as well. So here's our 2 answers for number 2 and now 4. And the last one to discuss is number 5, because it's a little trickier than it appears. So in my box, I'm going to say that my u is 2x and my du is 2dx. So it looks like an a is 1. And it looks like we are trying to line it up with the integral that looks like this one right here. So I have pretty much coming along to match this, but there is one discrepancy. Let's see if you can pick it up. When I go to make my u substitution from the box, do you see that I'm going to get, I need a 2, so that's not hard to handle. Pull out a 1/2 and put in a 2. So I'll have 2dx. And then in the bottom, I have the square root of a 2x squared, 2x quantity squared, and a minus and a 1 squared. So that's lining up beautifully. But I notice I've set this up, but what about x? We can't call it u because u is 2x. So I do need to make this in terms that I can, so far if I was going into u land, I would have a du over the square root of u squared minus a squared, which is nice, but there's still something that needs to be dealt with right here. And if you look in your box, it has to equal x, but it has to have u's in it. So I'm going to go to this statement right here and kind of extend my box. And notice if I divide both sides by 2, u over 2 equals x. So that's the substitution I can put in for x, and it's u over 2. That 2 is really a 1/2 in the denominator, so it'll come out as a 1/2. I can just pull it across the integral sign and it will cancel the 1/2 that is out there. So now there is a u there, and now it's exactly, and we can't really move ahead unless it is exactly like the formula. So the formula matches exactly, so we want 1 over a, arcsecant, absolute value of u over a plus c. So in this problem, that will look like, kind of keeping an eye on my box here, it will look like 1 over a, which is 1 over 1, so I won't even write that, arcsecant, absolute value of u, grabbing the u, it was 2x over a, which is 1, plus c. So very simplified answer. But you did have to go through all that who-struck to get it right. Alright, so I think that gives you the gist that these are actually done as u substitution problems to match the formulas. So we went ahead and signed numbers 7 through 12, and I wanted to shine a light on that for you so you can see what the problems are. So these are the ones where I think where the numbers were cut off. So we will do Where's 7? 7, right there. 7, 8, 9, 10, 11, and 12. So let me put a box around them. Hold on. Sorry. So going back there, did you get them? 7, 8, 9, 10, 11, and 12. And in addition, recall that there's some limit work for you to do. There was a handout, and we did a couple more assigned on another handout from the book and these. And I'm still waiting for your homework copies from your book, so please get that to me as soon as you can. All right, Allie, hope this is helpful. Thanks for working in the kitchen and serving us that way. And now you can catch up in math class. All right, hope you have a chance to watch this and hope you're having a nice weekend. And if there's not too much snow, I'll see you on Monday. Bye.